Okay, so this video is going to go over finding the x and y intercepts using algebra. Okay, so a few things first. Let's talk about what exactly are the x and y intercepts, and go from there. So if you have a graph, let's say here's a quadratic. The x-intercepts are these guys right here. They're where we cross the x-axis. Okay, but what do you notice about what's similar about those two ordered pairs there?
They're on the x-axis.
Yeah, good job, random student. They're on the x-axis. So the x values are different because they're going different ways. But what do you notice about the y value?
Looks like it's the same.
Yeah, it's the same. And what would that y value be? 0? Yeah, 0. So to find the x-intercepts, okay, we're going to set y equal to 0. And then solve. Now let's think about the y-intercept. Let's say it's something like this. Okay, y-intercept's right here. Well, that looks very similar, so we're across the y-axis. The y value is going to depend on where I'm crossing. But what do you notice about the x value? Well, it equals 0. So for my y-intercept, I'm going to set x equal to 0 and solve. Okay. Two important things to kind of note, though. Our answers are, the intercepts are ordered pairs. So we've got to make sure we write our answers as ordered pairs. The second one, this is a problem we might face. Suppose I gave you x squared equals 9. Okay? I told you to solve that. Well, you have to undo a square. How do you undo a square? Square root. So what's the square root of 9? You probably say 3. Be careful. Is there any other number I could square to get 9? Think about negative 3. Negative 3 squared is positive 9, so x could also be negative 3. So in this situation, when we go to take the square root of both sides, we produce two answers. And that should make sense if you think about our graph. That's a quadratic. Well, most of the time, quadratics have two x-intercepts. Okay? And this is kind of where those two come from. Okay, let's look at some examples. Okay, the first one here, y equals, actually, you know what? Let's go back. I think I'm going to need to erase some stuff. Yeah. Close your eyes. Let me just erase all this. Pause 1 second. Okay, so go to number 7. That should be the right one in your notes. Okay. Okay, let's find the x-intercept. So for x-intercept, we set y equal to 0. So 0 equals 3x minus 5. I'm solving for x. I'm going to plus 5 equals 3x. Divide by 3. X equals 5 over 3. Okay, that's my x-intercept. So I got to write it as a ordered pair. Well, the x value is 5 over 3. The y value, I set it equal to 0. Nice. Okay, now for the y-intercept, I set x equal to 0. 3 times 0. Okay, some students here might try to add 5 to both sides, but remember, we're solving for y. Y is already by itself. Leave them alone. So we're just going to do order of operations. 3 times 0 is 0. 0 minus 5 is negative 5. And then I write it as an ordered pair. X was 0. Y was negative 5. Okay, let's try another one. Okay, let's find the x-intercepts here. 0 equals x minus 3. Okay, got to solve this, got to get x by itself. Let's move the 9 over first. Okay, so now I got to get rid of that square. To get rid of a square, you have to take a square root. So square root of 9 is 3. Remember what we said earlier, the square root of 9 is also negative 3. So this is one of those situations. Now I have two x-intercepts. So x equals 6 and x equals 0. Okay, my first x-intercept, I'll put it up here, 6 comma 0. That's what the first answer told me. And the second answer, 0 comma 0. So those are my two x-intercepts. Okay, now let's find our y-intercept. Set x equal to 0. So I get y equals 0 minus 3 is negative 3. Negative 3 squared is 9. 9 minus 9 is 0. So my y-intercept is 0, 0. Okay, let's try one more together. Okay, do the x-intercept first. 0 equals 1/2. Add the 4. Okay, so now I got to think about, I have 1/2 times x. How do I undo that? Well, it could divide by 1/2. But remember, dividing by 1/2 is the same as multiplying by the reciprocal. So I'm going to do that instead. That's a little bit easier. Oops. Okay. Well, 2 over 1 times 4 gives me 8. And that equals x. So my order pair be 8, 0, from x-intercept. Okay, my y-intercept, set x equal to 0. So 1/2 times 0 is just 0. It's negative 4. So 0, Okay. Okay, for this next one, try it on your own, pause the video, and then come back and see how you did. Okay, we'll come back. Hopefully you pause the video and try it. X-intercept. 0 equals. Add 5. Okay, how do I undo a square root? Oh, I have to square. Make sure you square both sides. And then minus 4 divided by 2. So I get 21 over 2, 0. That's my x-intercept. Okay, my y-intercept. Okay, some students mix this one, or get a little bit tripped up here. 2 times 0 is 0, so that's just 0, which leaves me 4. That's 2 minus 5, that's negative 3, so 0. Okay, try this one on your own. Again, pause the video, come back, see how you did. Okay, welcome back. Okay, x-intercept. Add a third. Okay, it's kind of like the one we had earlier. I have a fraction out in front being multiplied, so I'm going to multiply by the reciprocal. Around the edges a little bit. Okay, when you multiply two fractions, you just multiply across the numerators and then the denominators. So x equals 5 times 1 is 5, 2 times 3 is 6. So 5 over 6, 0. That's your x-intercept. My y-intercept. Well, I'm just going to set x equal to 0, so 2/5 is gone. I'm left with negative 1/3. So 0, negative 1/3. Sometimes the y-intercept's a lot easier to find. Not always, but sometimes. Okay, let's try one more. This one's a little bit trickier. Try it on your own and then come back for some help. Okay, welcome back. Okay, the x-intercept. Okay, so you move the 5 over. Now to get rid of the square. So I know I need to take the square root. I don't know what the square root of 5 is. Okay, just leave it as square root of 5. There you go. It's just a number. Ugly, but it's a number. And remember, when you take the square root, you get a positive and a negative answer. Okay, I can solve each of these. So I'm going to minus 3. So square root of 5 minus 3. Cannot combine them because they're not like terms. I'll do this one at the same time. Then square root of 5 minus 3. It's pretty much the same thing. Just that negative sign there. Divide by 2. So x equals root 5 over minus 3. Okay. Okay. Now I have to write them as ordered pairs. Here's the first one. There's the second one. Oops. Definitely missing the y value there. Okay, so those are your two x-intercepts. Ugly numbers, yes, but can't judge a book by its cover. Okay, now let's come up here, do the y-intercept. 2 times 0 is 0. So I get 3 squared minus 5 is my y-intercept. 3 squared is 9, 9 minus 5 is 4. So 0, comma 4. Final thing I just want to talk about with these graphs. So we've seen the case where quadratics have 2 x-intercepts. Okay. We've seen some graphs that only have 1 x-intercept. Is it possible to have no x-intercepts? Well, think about that quadratic. What if I moved it up here? Yeah, so sometimes you can get graphs with no x-intercepts. Okay, now let's talk about the y-intercept. We've seen graphs with 1. Can I get a graph with none? Well, let's take that square root graph and, I don't know, move it over here. Okay, that doesn't have y-intercept. Can I get a graph with 2? Yeah, there are graphs out there that exist, but none that we're talking about right now. So right now we're only seeing 1 or 0 y-intercepts. Now, can you get one with no y or x-intercepts? Well, think about that square root graph again. And now let's have it go up here. Yeah, so in that case, we have no intercepts at all. So these are the situations that could happen. Okay, hopefully the video helped.